Hi, in this video I'm going to explain this example, which is actually going to be the first one using this topic of integration by parts. So at the same time, I'm going to explain the first example. I'm going to actually explain how to use this integration technique. So basically, this integration by parts rely on something quite nice. It's something that you should remember from differential calculus, which is this super nice formula of how to differentiate a product, which is normally called the product rule. So if you take a derivative of this u times v, you will get anyway to v times u prime plus u times v prime. That's the formula for this product rule. And now here comes the thing. Remembering out from this principle from the fundamental calculus theorem, if you start with an f of x and you move to the big f of x like this, you can move from the big f of x by taking a derivative, and you can move from f of x to big f of x by taking a antiderivative. So if I'm getting this formula for which is a derivative, if I apply to it an antiderivative to this expression, which is going to be u times v prime, which is the whole derivative. If I apply an antiderivative to the whole expression, like this, like this, then as you can see, this operation on the left, the antiderivative or derivative, this will cancel out this derivative, and we'll get this is equal to u times v, which is going to be equal to this addition of two antiderivatives. So we'll be complying with the fundamental calculus theorem, and at the same time we could use this information to find a way, another technique to solve out integrals such as this one. So I'm going to start actually something very simple. So if I say if you start with something super simple like this, just suppose you have this a it's equal to b plus c. Now, if you have a is equal to b plus c, you could solve this expression, for example, for c. In any case, if you solve for c, this would be equal to c. C would be equal to a minus b. Now, imagine what you have here. It's going to be, this is a, this is b, and this is c. So if you solve this expression to find and to get to c, it's equal to a minus b, in the terms of this expression that we have in blue, or sort of blue, I think it's blue, we will get to this. It will be the integral of u times v prime. This is basically a small little trick of algebra. So it will be equal to u times v minus the integral of v times u prime. And actually, this is the formula for what is normally called in textbooks and on the web to be called the integration by parts, this formula. So let's use it to solve out this example. It may not look like it, but it's going to be very useful. So first, I'm going to write a formula over here. So it's going to be the integral of u times v prime. This is going to be equal to u times v minus the integral of v times u prime. Okay. Now I'm going to say, well, let's suppose this x is going to be my u for the formula. So I'm going to name it over here. It will be u, it's equal to x, and now I'm going to call to be v prime to be this e to the x. I'm going to call v prime, I can write it down here, v prime, it's equal to e to the x. Now if you look at the right, but this side of the formula, you will notice that if you start here with a u, you will require, in order to fill completely this right side of the formula, you will require u and as well a u prime. Now, how do you find, if u is equal to x, here, its u prime would be equal to 1. So that's quite nice. We already have this piece, this u prime, we already have, we have the v prime, but we have to find anyway this v to locate in these two parts. So if we start with a v prime, how do we move and how do we find to get the v? Well, actually, this is just taking the antiderivative of this e to the x, which is going to be again e to the x. So now we had everything that we require to fill in the blanks with the right side of the formula. So let's just locate in each piece where it belongs. So it's going to be u, which u will be equal to x, and this u. Now it will be v, which is this e to the x, this e to the x. It will be minus the integral of v, which is again e to the x, and will be times u prime. Now u prime is equal to 1, so it's going to be here times 1 dx. Now I'm going to write this in a simplified version without this 1, and let's see, we get to x times e to the x minus the antiderivative of e to the x dx. So as you can see, well, this is something quite nice, because we got to this expression, we actually know what's the solution for it. So let's just write it down. It's going to be equal to x times e to the x minus, and this antiderivative is going to be just e to the x, and remember we have to add up this plus c, this constant of integration, and actually this would be the solution for this super nice example number 1. There it is. But now let's prove it. Let's prove it to be right. So if this is if everything that we've been listening the past minutes, it's true, if I take the derivative of this expression, I should get to x where we started, which is x times e to the x. So I'm going to do it down here. Let's see if we are right. So it's going to be x times e to the x minus e to the x plus c. It's a derivative, so let's see. Well, this first term, it's actually a product. So actually we'll be using this formula from over here. This is our u, this would be a v. So regarding this first term, the solution will be, let's see, it's going to be e to the x times 1. I'm going to do all the steps. It's going to be now x times e to the x. Now this second term, its derivative would be again minus e to the x, and the derivative of the constant will be 0. So let's simplify this out and let's see where we get. This e to the x plus x times e to the x and minus e to the x. And I believe we can everybody see here that this x, e to the x, is going to cancel with this one. And at the end, we got that this is equal to x times e to the x. That is where we started this expression, so it means we're right. And apparently this integration by parts actually works. So let's use it in a few more examples.